This video is part 2 of our exploration into behavior trees, where we'll continue to expand and improve our tree. Last time, we left off here with our agent capable of moving towards and through a door. Now we can expand on this and make it into this more complex behavior, where doors can be either locked or smashed down. To do that, we'll update our door script, adding 3 serialized variables: if the door is locked or not, the durability of the door, and the password to unlock the door. I'll add another variable to represent if the door is smashed, and update both the open and close functions. The door can be opened if it's neither smashed nor locked, and it can be closed if it's not smashed and open. Then let's add a function for unlocking that returns a bool and takes a string for the password. If it's not smashed and the password matches, then we can unlock and return true, indicating success. Next, we'll make a function to smash a door that returns a bool and takes in an integer that represents the strength level. If it's not smashed and the strength level is greater than or equal to the door's durability, we'll set open to true, smash to true, the hinge game object to inactive, disable the nav obstacle, and return true. Lastly, just for fun, I'll do onDrawGizmos, and if it's not smashed and locked, I'll call gizmos.drawIcon. In the gizmos folder, I'll add a lock icon and set the texture type to editor GUI, and use its name and the mesh's position in the drawIcon function. In the scene, the doors have our new settings, and now we need to create the 2 new actions. Let's create a new script for unlockDoor. Copy and paste openDoor and change it to call unlock instead of open. It will need a string for the password, and I'll make it a shared string here. Then send password.value to the unlock function. While we're at it, let's create the smash action. Copy and paste blah blah blah, add a shared integer, and call the smash function. In the tree, we'll need a selector and a sequence node as well as our new unlock and smash actions. Then, I'll make sure everything is assigned correctly by making 2 new shared variables for the password and the strength level. Let's say the door is locked with the very strong password of password and has a durability of 10, and our agent thinks the password is 123. We'll see that he fails both unlocking and smashing down the door. If he has the correct password, he successfully unlocks the door and can go through it. Inversely, if he had the wrong password but was strong enough, he could smash down the door and get inside. And since the tree moves from top to bottom, left to right, you can change his personality by shifting smash door to the left of unlock door. This will make them attempt to break the door first, even if they have the correct password. Though we've completed the example, let's continue expanding on it. Obviously, there is more than one entrance, and currently the behavior is enter door. We'll expand this behavior into enter building. To do that, we need to repeat this behavior for every door. An elegant way to do this is to use stacks. We can continually pop a door from the stack and apply the behavior until it succeeds or the stack is empty. So let's create a new shared object stack variable, and same as before, remove the class and replace it with a stack of Unity objects. Next, let's create a few stack actions. We won't use all of them, but they're good to have and might be useful in the future. I'll make a new script for pop from stack, push to stack, and is stack empty. To push to stack, we'll use both the runtime and runtime.task namespace and make a reference to the shared object that we're pushing and the shared stack that we're pushing to. We'll override the update and instantiate a new stack if it's null, and then push the object into the stack and return success. Then we'll do something similar to pop. If it's null or empty, the action will fail. Otherwise, we'll pop and return success. Lastly, for is stack empty, I'll actually inherit from conditional. The main difference between an action and conditional, at least in Behavior Designer, is that a conditional can be used with aborts, which are like interrupts. Conditionals can be set to continually evaluate and abort behaviors if its status changes, but that's a lesson for another time. Anyways, we will override the update and return success if it's either null or empty, and failure otherwise. Before I move on to update the tree, I'll create one more action called object to door. We'll declare a shared object and a shared door. In the update, we'll cast the object value and store it in the door and return success. Let's create a sequence to get a door, and it will consist of a pop from stack and an object to door. In our variables, we need to add a shared object stack and a shared object. We already have a shared door, so we'll have a stack of objects that will get popped and then casted. Then we'll set the variables in both our nodes and connect both branches with a sequence. Currently, this only happens once, and the question becomes, when do we stop? It should stop when either the agent has successfully entered a door or all the doors have been exhausted. One option is to use until success, but it'll trap the behavior tree if none of the doors are accessible and will continually try to pop an empty stack. And until failure has the opposite problem, where it'll stop at the first door it can't get through. A repeater could work with the right setup and extra nodes. As you can see, this is where behavior trees can get tricky, as traversing the tree causes you to lose context of why something failed without adding additional nodes. But in this case, I will create a custom decorator to suit our needs, so let's create a new script called stack repeater. The stack repeater needs to fail when the stack is empty and succeed when its child succeeds. Let's inherit from decorator and declare the shared stack that it'll be checking. We're going to override can execute, on child executed, on end, and decorate. Then we'll initialize a private task status called execution status to inactive. The stack repeater cannot execute if either the execution status is success or the stack is empty, otherwise it can execute. In onChild executed, we'll cache the child's status so we can use it for can execute. In onEnd, we'll reset the execution status back to inactive. Decorate happens after it can no longer be executed and is where you can modify the status that is returned by the children. If status is success, we'll return success, otherwise failure, which indicates it stopped because it reached the end of the stack. Let's add our new node and decorate the sequence of getting and entering a door and set the reference. Now, the most observant will realize that closed door can fail even if the agent was able to enter it. This happens in the case that it was smashed down. So this should always succeed as the behavior is entering, not entering and closing a door. To fix this, we'll decorate it with a return success. This is our final behavior tree, but we still don't have a stack to iterate through. So let's create a building component that will hold our door stack. I'll declare a public object stack property with a backing field, and it's important that it's a property so the shared variable system is able to pick it up. Then in the start, I'll initialize it with all the door components in the children. Back in the scene, we'll add that component to our building, and if we look at our agent, the shared variables see that there's a property that matches the object stack signature. Now we can reference the stack and use it in our behavior. In a real game, however, and not an example, you would probably use another action to get a copy of the stack. This is so you don't create a dependency and so the original stack is unaffected by the popping. But anyways, we're ready to test it. If we were to lock all the doors and give him the wrong password, then make the first door have a durability of 10 and his strength set to 5, we see that he fails to enter the first door and successfully enters the second door by smashing it down. If we were to increase the durability of all the doors beyond the agent's strength, we see that he tries all the doors and eventually fails at entering the building. Lastly, if we give him the correct password, our agent easily enters the first door and closes it behind him. Well, that's it. Certainly there are things that can be improved upon, and though this is a good example, it's fairly basic. But know that this is only just the beginning, and all I've shown you is the tip of the iceberg. This is still just a single behavior of entering a building without conditionals or aborts. This is all that I had planned, but you can grow your behavior tree by adding additional behaviors for exploration, survival, and combat. You can even give your agent animations so he isn't just a capsule. I hope that this helped you or that you found it interesting, but bye for now.